Hello and welcome back to the course on Python programming. To quickly recap on the previous tutorial, this is the solution, the proposed solution for the mini homework exercise. So to calculate player accuracy, we took field goals divided by field goal attempts. And then what I did here is I used the round function, but I rounded to 2 decimal points and then multiplied by 100 to get percentage. So these values here are percentages in terms of player accuracy, how many basketballs they get in the net out of the attempts that they take at the shot. So there we go, and using the same principles as we discussed with the dictionaries, we can create a similar approach to access different players in different seasons. One thing you'll notice is that even though that we have all the data, it is pretty hard to navigate because these matrices don't have column names or row names. It's pretty tedious to always find the player, always find their data. We can still do it, but it's just not as intuitive and not as simple. And at the same time, we can't, even though we have the data here, we can't really see the trends. There's so much information here that we get distracted and we don't see what's going on. And even though in this table, as we'll see further down in this section of the course, is a very interesting trend happening right now, we can't really spot it with just by looking at the table. So the question is, how do we proceed? How do we derive insights? As data scientists, how do we analyze this information to derive better insights? And that is a great segue into the topic for today, which is visualization. So today we're going to build our first visualization, and we'll finally start putting these tables of data into plots, which will allow us to see trends and anomalies and find out what we want to investigate further. So quite an exciting tutorial ahead, actually very exciting tutorial ahead. Let's get started. In order to start building visualizations, we're going to first need to do some imports. We're going to do our standard import of NumPy. And I say standard because it's already become quite normal that we do it. And in fact, we don't really have to do it because we've imported it before up top here somewhere. We don't really need to do it again. We can just rely on that. But as a habit, we're just going to put it here. And another import that we'll definitely need is a matplotlib.pyplot as PLT. So once again, matplotlib comes in the Anaconda distribution, so the way we installed Python in this course. If you installed Python in a different manner, then you might need to download and install this package separately or put it on your computer, and then you'll be able to import it. But otherwise, if you're following along these tutorials, you can simply run these 2 lines, and that will give you NumPy as NP and my pyplot as PLT. Another thing that we'll need to do in order to proceed, because we are using Jupyter notebooks, we need to specify this line, matplotlib inline, and what that will do is it will put the plots in the actual Jupyter notebooks rather than putting them in a separate window, which can get quite annoying. So if you're using Jupyter notebooks, then definitely specify this line and run it. You only need to do that once, just as with the imports, and that way the plots that we're going to be creating are going to be shown inside your Jupyter notebooks. All right, so let's get started. We're going to create our very first plot. How are we going to do this? Well, in order to create a plot, we're going to say plt dot, and here you can click tab, which will bring you a pop-up and it'll show you all the different items available inside plt, which is pyplot. And the one we're after is called just basically plot. So if you look here, this is the one we're after. Oh, let's do it again. Tab, where was it? PLT. So just plot, and we'll just basically type it up there. That's what we're after inside this plot. Like, I know there's going to be quite a lot of new stuff right now. Just bear with me. We'll go through it bit by bit, and then we will see how this plot is coming to life. All right, so first thing is we need to supply some data to this plot, and we're going to supply salary. So from our salary matrix, we're going to take the first row, which is Kobe Bryant's salaries, right? So let's finish typing, of course, salary, first row, or row number 0. So if I just run that by itself, you'll see that we already have a very descriptive plot. So we can see that Kobe Bryant's salary started here at 1.6, even though we can't really tell what this 1.6 means right now, and went all the way up to 3. To tell what the 1.6 means, we just go to salary, just quickly have a look at what we have there. So 1.6 is basically means $16 million, and the 3 is actually $30 million. All right, so just for our reference. So that's the very basic thing. So you can already see that it's quite a smart function. It takes your salary, which is just basically a list of numbers, as we saw, and it puts it into a plot. So it knows to add these on the x-axis, and then plot the values on the y-axis. So it's already quite interesting. So let's start building on top of that. We're going to give this a color. So C stands for color. It's a parameter for this function. We're going to say black. So if we run this now, you'll see that the the line has become black. LS stands for line style. What we want is dashed. So just put 2 minuses. So if I run this, you'll see that now it's dashed. So we're kind of styling our plot as we're going. Then what we want a marker. And you'll see why in a bit, because we're going to soon have more lines on this plot. So let's put a marker, and S stands for square. And it's very simple to look all these things up. So you can just look up matplot line styles. You'll get the different codes for line styles and get different codes for markers the same way. It's all in the documentation, can be found online. So then we can say MS, which stands for marker size, let's say 7, which kind of is already 7. So just to show something, you can see you can increase them. We can say 17, or let's just keep it at 7. Okay, so that's a good start. What else we want here is we want to get rid of this line. It's just showing there because we're sending the object. You know how we use print to print values. So here we would say plt.show instead of just sending the object into the output, and that gets rid of that line. So it looks good. And one more thing I wanted to do is I wanted to kind of make it bigger, so expand it to the right. We've got a bit of space, so let's do that. That's also a line that we just need to run once. Let's just type it up. It's plt.rc_params. So basically we're setting the parameters of our session fig size. It's just something that needs to be remembered, I guess, or you can always look it up when you need to. And so now if I rerun this, you'll see that it's a bit bigger, so it's being stretched out, right? If you want to make it even more bigger, especially if you're not zoomed into your browser, then you can definitely make it bigger here. So change it to a 6. You'll see that it's starting to take up more space, but I want to save some space, and still I want to be zoomed in so that we can see all of the code. So I'll just keep it at 8.4. So these things, again, there's no need to actually remember them off by heart. You can always just look them up when you're plotting to change your size. And it's not the only way. So there's other ways to change the size of the plot, but for now, this will be sufficient for us. Okay, so that's a good start. What we want to do next is, we'll just copy this over here. And what we want to do next is we want to add the ticks on the horizontal axis. So we don't want 0 to 9, we want the actual dates. So the way to do it is to use plt.xticks. And the way we're kind of approaching this visualization challenge, is so much to learn about visualization, and we'll definitely jump into visualization in more detail in one of the further sections of the course. For now, we're just learning the bits that we need specifically for this challenge. I'm going to explain as much as I can, and that will give us a head start into visualization. Even though we won't know everything, we'll know how these things are structured, and that's a very valuable skill to have. So just follow along with the code, and I'm going to now add these tick marks. So in order to add tick marks, what we want is ultimately we want the seasons, right? So we have this seasons list, which has the years. We want it to be displayed here, right? So what we want to specify for xticks is what is the output, and also what should be replaced. So we need to replace. We're going to create, as we learned way back at the start of the course, we're going to create a range. So create a new line. So if I run range by itself, in Python 3.0, it's the same as xrange in Python 2. So basically, this is not a list yet. In order to turn it into a list, you have to do that. So basically what this is just basically a list of numbers 0, 1 to 8. Actually, we need 0 to 10, not to 8. So there we go. That's the list of numbers, and I'm placing it in here. And then I'm saying that for the ticks, I want to see the seasons, not the numbers. So if I run this now, you'll see that I actually have the seasons, and we can get rid of this. And one more thing that we can do, just for aesthetic reasons, we can say rotation equals vertical. So as you can see, it's all pretty intuitive stuff, and they try to use very intuitive words as well. So rotation vertical, there we go. So we've now rotated these around. One more thing that we're going to add here is we're going to say label. We're going to label this line. I know it doesn't really matter right now because we only have one player on this chart, but going forward we will have more, so we will need that. And again, because we want to make it as generic as possible, we are specifying through the salary matrix. So we could have just said, and here for the players matrix, we could have just said Kobe Bryant as text, right? So we could have said Kobe Bryant because we know that it's him. but at the same time, we just want to be able to then replicate this same line for other players. So it's just easier if we specify it through the players list. So if I run that, you'll see that nothing pretty much has changed, but that label has been saved for that specific line. So there we go. That's what we wanted to do in terms of the box itself. Going forward, what we want to add to this plot is we're going to start adding other players so that we can compare them side by side. We'll get started on that in the next tutorial right away. But for now, if you would like to play around, what you could do is you could just change the player here. You could just change this and this value, 0 and 0 here, and see what you get. So you'll get different charts for different players. But then don't forget to change it back so we can continue straight from here in the next tutorial. And I look forward to seeing you next time. Until then, happy coding.